Hello Year 12, we are now in a new section of our OneNote titled Integration, and that's our next topic. This will be examinable in our first Year 12 assessment task in a couple of weeks, so you need to get pretty comfortable with this topic. We started this topic did one exercise that relates to this at the end of our graphing with calculus chapter in 3H. We looked at the primitive function, and that's where this topic starts at. Now, if you have a look over here, the primitive function here, these notes we've actually already done. We've done in 3H. So I'm not going to go over these ones. You can fill them in if you like. It'll be a good bit of revision to fill in these from 3H. We're going to carry on with that and look at the next section, which is chapter 4, and look at, we're going to start at 4E. So if we scroll down to the next section, I've left a blank page for you in there. We're going to be having a look at indefinite integrals. Now this relates back to our textbook in section 4E. So we're still finding the antiderivative or the primitive function. What we now have is this symbol here. Okay, that symbol is telling us we want to integrate or find the integral of the function that is in there. And it has a little dx on the end of it. That dx basically means we're relating our integration to x in this case. So our integratable variable is x, and this is telling us, yep, in relation to x, basically. That's how we're going to think of it for now. So if I was integrating x to the power of n with respect to x, my primitive rule that we looked at before is the same as what we're looking at here. We add 1 to our power, or our index, becomes n plus 1, and then we divide by that new index, and we always add a c. We're adding a c because what we're looking at the moment are indefinite integrals. We don't know if there is a region in which this is existing. We're down the track going to pop some values up and below our integral symbol, and that will make it a definite integral. But for here, we don't know what's happening. We don't know whether when we our original function had a value at the end by itself, so we must always add plus c. Let's have a look at this one. We're finding the integral, or the integration of ax plus b all to the power of n, and it's all with respect to x. So here we differ from our first one over to the left, where we just had an x to the power of n. We have a whole function to the power of n, and we have an extra little tip or an extra little thing that we need to do for this. So when I'm finding the primitive of ax plus b to the power of n, I'm still going to add 1 to the index, so I get n plus 1, and I'm still writing that function in there. I'm still dividing by that new power, n plus 1, but you'll see there's an extra a here. What I need to do is differentiate ax plus b, and I will get a, and that a also goes down the bottom. So that's our rule if we have an integration of a function that has a power to it. Now let's work through the examples here. I want you to work through these. You may find that these are quite simple, and that is excellent, and then in which case you might just want to fast forward and check my answers. Okay, step 1, we are going to find the primitive, or we're going to integrate 4x to the power of 7. So the rule says what we do is we add 1 to the power, so 7 plus 1 is 8. I still have a 4 there, and I need to divide by that 8 plus a constant. 4 and 8 cancel down to be a half. X to the 8 plus c. And I don't need that 1 out the front there, so I'm going to remove that. So it just becomes x to the power of 8 plus c. Fairly straightforward. We've just got to remember that plus c. Let's have a look at our next one. Let's find the primitive of x to the power of 3 minus 3x minus 7. Or with respect to x, notice we've got x's in here. That's what we want to integrate in terms of. X to the power of 3 becomes x to the 4 on 4 minus, I've got a 3. My x becomes, it's a 1, it's going to go to a 2 over 2 minus 7. It's like it's having an x to the power of 0 here. So when I add 1 to it, I become just x to the 1. But I don't need that 1 in that power to be written in there, so I won't write that, but we know that that's what that means. Divided by 1 plus c. Let's keep going. Okay. 3 is a little bit different. we have x's on the top, we have an x on the bottom. At this point, we don't have a rule to deal with this, but I can simplify this. So I'm going to write it in a simplified form before I integrate it. So I'm going to write my integral symbol there, and I'm going to divide each of these top terms by my x. So if I get 4x to the 4 divided by x, I'm just going to have 4x to the 3 left. If I divide 3x to the power of 3 by x, I'm going to have 3x squared. So I'm basically crossing that off one of those, and it goes to a 2. Lucky last, I'm going to divide 7x by x, and I'm just going to have 7. And this is my new function that I'm going to integrate. So we've just simplified what's up there. So let's do that. Same rules as before. I've got a 4 out the front. I'm going to get my x. I'm going to raise it to the power. I'm going to divide by that new power. Plus, I've got a 3. I'm going to raise my x to the power. I'm going to divide by that new power. Minus 7 is x to the 0. It now becomes x to the 1 plus a constant term. I can easily simplify that out. The 4's will cancel. The 3's will cancel. I'll get x to the 4th plus x to the power of 3 minus 7x plus c. Okay, you might notice each of these is slightly different from the one before. Okay, we are now going to integrate 1 over x to the 3 with respect to x. I can't do that as it stands. I need to write it as a negative power. Now it's workable. I have my x. I'm going to add 1 to the index. Be really careful. Minus 3 plus 1 is not minus 4. It is minus 2. Divide by that new index plus c. Please don't leave it in this form. Okay, there's a minus on the bottom. We do not want the minus on the bottom. I'm going to put the minus on the top. So you could write it like this. Okay, that's okay. I'm not going to write it like that because I would like to write it without a negative index. It gave it to me in the form without a negative index, so let's write it in that form as well. So I'm going to have minus 1 over 2. Okay, the minus is still there. The only thing that's going to the bottom is the x and the 2. Just like that, plus c. So you need to know how to change from this format to this format, and it's very good practice to do that here for us. Let's go up to number 5. Okay, this one will have a similar idea, is we can't have our square root of x on the bottom. So to integrate that, I need to write that as x to the minus 1/2. We're integrating that with respect to x. Now I can do it. I'm going to add 1 to the index. Minus 1/2 plus 1 is 1/2. I'm going to divide by that new index plus c. Let's neaten that up. When I have 1/2 on the bottom, and I'm dividing by it, I flip it upside down and multiply. It becomes 2. I can leave it as x to the 1/2. I'm going to write it as the square root of x because that's how I was given it. So let's give our answer the same way. Next one. Okay, this one is the second rule that we had up above. We are integrating in brackets with a power, but in those brackets is a function. So we need to also remember to divide by our minus 2 in this case. So our rule will be, let's write down what we have in our brackets. We have our power of 3. Let's add 1 to that power of 3 to get 4. Let's divide by that power of 4. But we also need to multiply by the differentiated part inside our brackets, which is minus 2. So what I will end up with is 3 minus 2x to the 4 over minus 8. I'm going to put the minus out the front because I don't like a minus on the bottom line. What are we missing, guys? Plus c. I need to pop that in. Okay, let's do this one. Similar to the one above, but what we have is we need to write our function on the bottom line in terms of a negative power so that our rule will work. And we're integrating with respect to x. So what I'm going to do is leave my 3 out the front. I'm going to go 3x minus 2. I have minus 5 plus 1 becomes minus 4. I divide by my new power of minus 4, but I'm also going to multiply by the differentiated version of what's inside my brackets, which is 3. Now, we need to add c, we can do this quite simply. You might go and multiply the bottom line out to be minus 12, but you'll still need to break that down and simplify it with the 3. I can see here I have a 3 and I have a 3. They can go. I'm bringing the minus to the top line. Minus 3x minus 2 to the 4. I just don't like to leave that minus on the bottom line. I could write it like that. However, we were given a question with our function on the bottom. So let's get rid of the negative indice and write it like this. Minus a quarter, and on the bottom becomes 3x minus 2 to the power of 4 plus c. Lucky last question. I think you'll have gotten this by now. If you need to pause it and do it, do that. Let's rewrite this question as 2x plus 1 to the minus 1/2. And then we're integrating with respect to x. Okay, let's do it. Quite simple. We have our function. We're going to add 1 to the index. So minus 1/2 plus 1 is 1/2. We are going to divide by that new index. But we are also going to times by the part in brackets differentiated, and that is 2. These guys will cancel out to 1. Plus c. And we're going to have left 2x plus 1 to the half plus c. And you might be asked to write that without a fractional indice. So you're going to have 2x plus 1 plus c. And that is our answer. Now, that will get you through exercise 4e. We are starting with 4e because it just makes a heck of a lot of sense to be able to integrate before we understand a little bit more about what it means. So make sure you're familiar with those rules. They will go on your formula sheet to take in with you for our first summary aided assessment task. Pop some examples in there. And note, this is an indefinite integral, okay, where we're adding plus c. And we'll have a look at a different version of that in the next couple of days. Okay, off you go.